a standard duplex reticle into something that's more useful, and you can actually reach out to range instead of going, I don't know, I held a foot over his back, you know, that kind of stuff. So now we can actually utilize this, and you can continue to back down your power ring, all right? So as you do that, you can work further down, and all these numbers will change. But again, you can go out and shoot it, but it's much faster. Once you know what each line represents in mils, it's pretty fast to run it through a ballistic computer. If you know your muzzle velocity and your ballistic coefficient, your density altitude, you can actually run this through a ballistic computer or ballistic solver and actually have real precise holes all the way out to distance. Yes?
Got a question for you, Todd. If you back it off a little bit more because you're trying to work on getting a little bit further with your scope, would your center crosshair, no matter what, always stay at 254? It's just that you pick up more mils on the bottom. Is that what's happening here?
Yeah, absolutely. And really, basically we're zeroing here, you know, at 100 meters, but really we're zeroing at 100 meters for 254 meters is what we're doing. That zero is going to stay constant. As you run through your power ring, it's not going to change. All right, so this is old school stuff. This is what we used to utilize, and it's still a really good tool today. All right, now we've stepped up into mil dot reticles. Again, we have the heavy duplex, and the heavy duplex at, you know, at low light actually helps us sometimes see exactly what we're aiming at. The crosshairs, you know, if you're not utilizing illuminated reticles, a lot of times the crosshairs kind of get to where they get washed out and we can't see them. So the heavy duplexes really kind of help us pick up what we're aiming at the time when there's no light. All right, same thing with this. What I decided to do, instead of using a lot of max point blank like we did in the past, or running 500 meter hold over, hold under drills, what we ended up doing was actually zeroing here at 100 meters. All right, if you're working with a mil type turret, you can actually dial 5 mils up and put your 100 meter zero up here at the top duplex. All right, what this gives us, if you're working with a TMA scope, it's 17.2 minutes of angle equals the 5 mils. So if you're running either one, you're going to have to dial. If you're dealing with minutes of angle, you may only have 17 minutes is all you can dial. If you're in a quarter minute, you can dial 17.25. All right, but that gives us the same thing to where we're zeroed up here at the top. Now what this does, instead of doing like a 500 meter hold over, hold under drill, all right, or having a 300 meter zero on your gun and you're actually, you know, up in the top portion with your crosshairs for 100 meter, not your crosshair, but your actual hold. This allows us not to have to do math because that's what it's all made for. So basically what we call this is a poor man's horse. The poor man's horse allows you now, if I'm looking at a target and I say it's 305 meters, I know my mil hole's 1.5, I'm gonna put it right here. It's 1.5 mils down from the top. I know if I'm gonna shoot 400 meters, it's 2.4. So I'm gonna hold here. This would be 305, this would be 400. All right, if I know my holes for 600 is 5 mils, this equals 600. All right, so right now, very quickly, if I already have my dope sheet in my scope cap cover on the side of my gun, or I've memorized my holes every 100 meters out, very quickly, if I say, hey, I got a target at 780 meters, my hole's 8.2, all I have to do is look down and go to 8.2 and hold. So it's a very refined way to do this. Now, the problem that you're gonna run into is when you start getting out here on wind calls. All right, because holding out in space, and that's one of the huge benefits of the horse reticle, is that we always have a refined aiming reference point with the horse reticle. When you're holding out here in space, for one, it's hard to actually know exactly how much you're holding out. The other problem is when you actually think you're holding here and your bullet impacts here, you break that shot, you fall back down under recoil. The next thing you're gonna see is, all right, I see the puff of smoke or I missed my target, now where do I make my adjustment? You don't have any good measurement to go off of. It's not very quick. So a lot of times we have the guys actually go ahead and dial their wind if the wind's blowing like it does out here. So usually, I never tell the guys to ever dial wind, all right? We always hold for wind because things change. In a tactical environment, you may have a mover and you're holding, you know, two mils for a 4 mile an hour mover or 2.2, and you also have wind. So you're holding for both of them, but if that target actually turns around and moves the other way, now you have to start taking it off, and if you've actually dialed it on, now you're reaching up there and jerking stuff off and it's slow, and if the target's moving left and right, you know, it's kind of ridiculous to be dialing. For right now, we're just doing pure holes. This is the only time I actually tell guys go ahead and dial for wind, is when we're actually using a poor man's horse like this. It's still a mil-based system. All right, so we can still use it when we're doing meal relation formulas to figure out how far away the target is. You can actually take the size of the target. If the target's 12 inches, divide it by what you meal it. If you meal the target at 0.8 meals from here to about here, if the target meal's that size, the target's 381 meters away. All right, so you can utilize that by going 12 divided by 0.8 meals. All right, once you do that, times 25.4 will give you 381. Now, if you're working in yards, you'd times 27.778. All right, so you can still utilize this the same way it was meant to be utilized. This is just a more refined method of utilizing a standard duplex. All we did is start adding in dots all the way through. All right, now, once we went from this, a lot of guys started
Quick
going.
question for you, Todd.
Yep, go ahead.
Before we take that down, how do you find the system works out with using a more traditional mill dot system like the old oval-shaped USMC mill dots?
You know, I really didn't like the oval. They were 0.25 tall. You know, this is actually pretty good because you can actually take and refine it a little bit. All right, we'll make them a little bit larger. In some of the better systems, mill dots, there's a lot of different types of mill dots. Some have half mil subtension marks like this. All right, and then once you get out here, all right, some reticles actually look like this where there's 0.2 subtensions. All right, this is on left, right, top, and bottom. All right, so again, it's a good way to actually mill a target out. Anytime it is subtended more, what you're going to find is you can actually more accurately mill that target. Instead of looking in here and going, I don't know, the target's from here to here. All right, well, that's a little over a half. It may be 0.6, maybe 0.65. I don't think it's 0.7 yet, but we're guessing. We're trying to extrapolate, and that's the problem right now. So when we actually changed the reticles and we gave them half mil marks, all right, it made it much easier to actually guess and actually kind of figure out what the mills were. So if that target was milling from here all the way to there, now it's a little bit easier to see that's probably closer to 0.7 right there. All right, so our eyes can break it up a little bit easier, all right? But as we go through and we start talking about the horse reticle in a minute, you're gonna see it's real easy to refine your milling to where you can very accurately get a range estimation. All right, the next reticle that we really kind of got into for a while, all right, was basically just a ballistic reticle. On ballistic reticles, you start out and you have 200 meter hold here, 300 here, a little bit further down, you go 4, 5, 6, 7, 8, and so on. Now, the thing about ballistic reticles, if you actually work with a ballistic reticle and it's made for your weapon system, your BC, it's kind of like a bullet drop compensator on your turret. You'd auto 200 for 2. All right, so you'd put the 2 for 200, 5 for 500. All right, they both have the same problem. The problem is, this is set up, ballistic reticles and ballistic drop compensated turrets are all set up for 1 density altitude, 1 muzzle velocity, 1 BC. Unless you're hand loading and staying in your own environment and not changing bullets, if you don't, that's fine. It's a very accurate system. And if you're out here, you know, shooting in West Texas and it's using the same reticle and you're not going up to 8,000 foot hunting elk or something, this reticle works. But the problem with this reticle, the equivalent hold for this right here for 800 is 8.5 on the classroom gun that we've been running. All right, now if you jump up to 8,000 foot, your hold for 800 meters is really 7.5. All right, so this dot's gonna miss by a mil, all right, at that distance. You're looking at 26 inches for a miss. All right, so ballistic reticles really quit working after about 400. Now at 400 meters, you're only probably a half a minute off or so. All right, so it's still a good reticle out, you know, if you're hunting and you're not gonna take a shot past 400, that's where your limits are, that's what you set for yourself. Ballistic reticle is a good reticle. There's nothing wrong with the ballistic reticle. But after 400, you're gonna start seeing that separation. You know, last year we came in here and we was shooting training and I jumped up and went up to Colorado and shot an elk with my buddy. He borrowed my gun and he took a shot at an elk at 1,153 meters. He hit him with the first shot. We zeroed the gun here, trued it here, changed our atmospherics, went up there and hit the target. If we was using a ballistic reticle, it wouldn't have been even anywhere close, you know, even with the 338. So what you gotta understand is ballistic reticles, where they work and where they quit working. All right, so from 400 meters and down, not so much as you change altitude, all right? And that's another thing, most reticles are kind of set up at a average density altitude. You don't want to set one up for sea level and you don't want to set it up for 8,000 foot they set it up in the middle to kind of cut the air in half both ways as they go up and down. The environment that some of our guys hunt in and the environment that our military boys fight in, you know, whether it's in Afghanistan or high up in other places, you can't utilize a ballistic reticle. It's not a system that will actually work.
Hey Todd, I'm gonna hold you for a second. I guess also you're not just talking about density altitude, but if you change that gun or that ammo or any other facet, that thing's getting affected at that point. I mean, that's just, you're just covering right now. If you went from, say, you know, Florida to up in the mountains, you're going to be affected. That same gun, same bullet, same hand load, same everything. But if you changed it round at that point, you're...
Oh, absolutely. What you're going to see is, you know, you could actually take a standard MilDOT reticle and put it on your 338, and you could pass it off and hand it to Mike and say, hey, try this on your M4, and he's good to go. It's a good system. It'll continue to work. But you take a ballistic reticle and your gun fell off this truck right now. Now you have to find another 308 ballistic reticle shooting the same ammo. You can say, hey, let me borrow that 300 Win Mag, you know, let me take the scope off it and put it on this gun. It won't work, all right? So it's a huge point. A lot of times, you know, we like the capability to swap scopes from one system to another. I used to have people tell me all the time, man, I can't afford a Smith & Bender scope. They're kind of pricey. And I go, well, how many rifles do you have, you know, hunting rifles? And they go, oh, I've got 6 or 7, you know, in the house right now. And I said, how many scopes you got on them? They go, 6 or 7. And I go, okay, what'd you spend on your scopes? $400 to $800? And they go, yeah, I've got one cost $1,400. I said, what if you sold all your scopes, bought the best glass made to man right now, and then put it on a ring that you could actually take it off, move it from one weapon system to the other? Now you're shooting the best glass made, all right, and enjoying the full capability of your weapon system. And you try to tell people all the time, they'll go out and they'll spend $3,000 on a rifle and put a $400 scope on it. You know, if you're spending $3,000 on a rifle, it's really kind of smart to go ahead and spend $3,000 on a piece of glass, all right? The glass is actually more important than the gun is. Most weapon systems today, I mean, you can buy some really nice Tikka rifles, hunting rifles, you know, and they're not very expensive at all. You can get $500, $600 rifles. They're very accurate. They're minute of angle rifles. Put a $1,000 piece of glass and you're going to maximize the benefits of accuracy that you're going to get out of the weapon system. But if you take a $3,000 rifle, custom made by Tactical or Surgeon or any one of the great, you know, gunsmiths out there today, and they're making good weapon systems, and put a sorry piece of glass on it, you still got a 2-minute of angle gun as far as the effects that you're getting on target, you know, because it just changes. You know, if you're working with a really good piece of glass, you're going to maximize and get the benefits of whatever that weapon's capable of. And most of the guns are very capable that are made today for the hunting market, and as well as the tactical side, very accurate. But the big deal is we really need a good piece of glass. But let me show you something else that we was talking about a little bit earlier. All right, when we was going through second focal plane. All right, back to the MilDOT reticle. If you're dealing with second focal plane reticles, in second focal plane, a good way for you to know if yours is second focal plane, when you look through it, all right, you've got your reticle and you got your target. If you decrease your magnification, if your target shrinks in size but your reticle stays the same size, that's second focal plane. The problem with that is you can only mill at max power really effectively. But there's other things that we can do with it, all right? So if I go ahead and I actually zero here and I turn down to half power, and again, you have to utilize the same thing because not all dials actually equal what they say they do, all right? So if we cut it down to half power, each one of these MilDOTs is now worth 2 mils, all right? So if I'm wanting to extend my range and I do the poor man's horse and I zero up here for 100 meters or 100 yards, all right? Now, this is zeroed at 5 mils, or the equivalent of 5 mils for range for whatever weapon system I'm working with, and this is equal to 10 mils. All right, same thing as we talked about a while ago. If I cut it down to half power, this now is 100 meters, all right? And then, what do we have here? This is still 5 mils, but this is worth 10 mils now. So I have a total of 15 mils that I can actually utilize. Again, we can continue to decrease, all right? So if you have a, let's say a 4 to 14 power scope, 7 power would be half power, right? But what if you was able to come all the way down? What if you divided 3 into 14? That would tell you what each MilDOT's worth, all right? If you were down at 6 power, 6 into 14, that tells you what each MilDOT is worth in mils. All right, so you can actually really start to push out your range with the current systems that you have right now. You don't have to run out and go buy a, a Smith & Bender scope with a Horus reticle. This is good knowledge. It's a good way to utilize it because you never know what kind of weapon system or a scope or reticle that you're going to be running.
I think that's an interesting point you bring up, because in most instruction sets, people say you can only mill at full power. And if you really know that magnification ring and how to set that, effectively what you're saying is you can effectively mill a target at half and possibly quarter power.
Yeah, you can. The only real problem with doing that, though, is, for one, the target gets smaller.
Sure.
All right. And as that target gets smaller in a second focal plane scope, it's going to be harder to mill. When you're doing UKD shoots or unknown distance targets, the problem is that target, as small as the targets are that we shoot at, when you start backing out that magnification ring and you don't have much power to work with, it's very hard to mill that target at that size. But the biggest problem is the calibration of your actual dial, knowing exactly where half power is. So again, biggest points here are calibrating our reticles, making sure that everything is matching up with the dials. The other deal is, guys, when you're dialing turrets, you really need to make sure that you've actually calibrated and made sure that what that turret is turning is actually happening inside the scope. All right. So as you're turning that turret, you may dial 5 mils, but you may not be effectively getting 5 mils out of that turret. It's a man-made mechanical object. Sometimes they're not that great. And I've seen a lot of them that you dial 5, you get 4.5, especially when we start shooting out to the ranges, that we're looking at. Now that was an extreme, is being a half mil off at 5 mils. But when you dial 20 mils, it's not uncommon to only have 19.5 actually being dialed onto that scope, or having 20.3 or something like that actually on the scope at that time. So another way, like we talked about the cat's target, it's a real cheap piece of paper, and you can actually, use a ruler or something, a yardstick, and actually draw it off. We talked about 100 meters or 100 yards. If you go 100 meters, you need to have 39.3 inches, at 100 meters to have 10 mils, where you at 36 inches is what you need for 100 yards. All right, so if you take a ruler and you mark it off and you're exactly 100 yards, and you really have to be exact on that, but it'll equal 10 mils, and you can start calibrating and figuring out what your dial is, how much, turrets that you actually have as far as how effective they are. And we'll actually show by shooting the cat's target that when we shoot at the little box on the bottom, and then we actually dial 10 mils and shoot, and it actually hits on the 10 mil line, or dial to 20 and it hits on the 20 mil line. I tell the guys it's something like the old commercial used to say, moose hunt, $7,000, flight to Alaska, $600, guide service, this, that, taxidermy, a calibrated scope is priceless. If you don't know what you're getting out of it, I was shooting in a competition one time, and I wasn't real used to that scope. I was actually shooting a Horus reticle in that manufactured scope, but the turret wasn't actually correct. So at 4 o'clock in the morning, when we're shooting movers in this competition, it was real dimly lidded mover, was 500 meters back. I dialed up 3.5 mils, my hold for 500 meters, because I didn't want it to be in that bracket. I was real new to using the system. So I dialed 3.5 and missed a whole bunch of targets that night, all right? And couldn't understand why until I took my scope the next day and checked it, and 3.5 mils wasn't equivalent to 3.5 mils. But that's experience, Tried something, figured out from that point on, if you're ever gonna dial, you need to know exactly what that dial means on your scope. So if you dial 5 mils, know that it's 4.8, or know that it's 5.3, or know that it's 5 mils exactly. A lot of the scopes that are made today, good quality scopes, usually are pretty close, all right? But that doesn't mean all of them are. So it's something that we actually need to check, all right? So now, the next reticle that we're actually gonna go into is a Horus reticle. All right, the Horus reticle is basically subtended 0.2 mils all the way down left and right, all right? So, and it also, when I say left and right, it gives us wind as well. So if you look at what we're looking at here, you'll have lines. It's a gridded reticle, all right? Has 1 mil marks all the way up, and then it's subtended at 0.2 mils all the way across. Now initially, if you're like me, first time I looked at it, I said, oh man, that's too busy. I don't like it, all right? After the second day, I said, all right, I got it. I can see there's some major benefits here. I'm not dialing, I'm not leaving the wrong dope on, I'm always just doing holes. I can see if I can see my impact where I missed, very quickly I can do a second shot correction. I can mill much better utilizing this than the standard mill dots that I've used in the past. And so I started to get around it a little bit, but it was one of those things that I really didn't like it. I still thought it was a little bit too busy for me. The more I shot it, by day 3 and 4, when I woke up on morning 4, I was already trying to figure out a way to, you know, get a good guy price on one, because I was already sold. Once you've actually utilized it, what you're gonna see is you actually look through the lines and find the target. All you utilize the lines for is a reference point as far as an aiming point to utilize for aiming. So when you actually look at the reticle, at first your eyes are focusing on the reticle. But once you start using it, you realize very quickly your eyes are focusing on the target, and then you just find the actual hold that you need to hold on the target, and that's the only part of the reticle that you actually see. A lot of people say, yeah, it's too busy, I can't use it for observation. There's many guys that do, all right? So that's already been debunked. I've heard you can't shoot movers, you can't shoot snaps, you can't, you know, get lost in the veg, and none of it's valid. You know, we've actually tried it. You know, we can actually shoot anything that we want to shoot as far as reticles. If my son goes down range in a couple of years, this is the reticle that I want him to have, because I know the benefits of it. I know what it'll do for him. You need about 4 days on the horse reticle to really get wrapped around it. You know, I have a lot of guys that actually try it and then they put it up and they go, oh, it's too busy, I really didn't understand it. It's really just another meal-based system is all it is. There's nothing wazoo to it. You just don't have to dial anymore.
Well, that's
you know?
the biggest problem with
nice.
our society, specifically when we're talking military and when you get into special types of groups of people, A-type personalities, obviously. That's what we do. We look at it and we're like, ah, it's too busy. We shoot it a couple times, like, nah, I'm used to what I'm used to. I'm at that comfort zone. And that comfort zone should be an alarm in our heads that go, hey, wake up, I need to think outside the box here. And that's what I've been doing, looking through this system now. Every time I look through it, I find if I look through it consistently and keep tracking that thing, it just gets easier and easier and easier. And it's just like anything else we do in life. Driving a vehicle, the first time you jumped in a truck when you were 15, 16 years old, were you comfortable? No, you were like, oh my God, you know, you're trying to look for every little line and not hit any oncoming traffic, but now you're drinking coffee, texting, and driving with your knee at the same time. So it's like anything else, it'll come.
First time in a helicopter, you know, you're kind of hanging on, don't know exactly what's going to happen. Is that pilot any good, you know? Then the next time you're hanging out the side, shooting at coyotes, you know, it's that progression, you know, and it's the same deal, it's comfort zone. So initially when we look at it, because we may not understand it, we don't want to give it a try. Because it's like, hey, I don't understand it, so I'm not going to be the guru on this anymore. But once you look at it, it's just a meal-based system. It's just refined so that now we can meal better. We have more reference, you know, as far as aiming points. And there's nothing different. There's nothing wazoo. It's just a very basic reticle once you actually apply it.
It's common sense.
Absolutely. All right, guys, so as you can see, there's a lot of different reticles out there that we can utilize. The biggest point is don't get locked in that old school method. You know, expand your horizons, get out of your comfort zones, learn how to use the one that you have better, and look at what others have to offer. All right, so play with the PDA, look at the math, go through it, none of it's hard. Rewind the DVD 2 or 3 times and you'll figure this out really easy. This isn't rocket science, all right? So it's just very simple math as you go through it. Back to the basics, it's just the fundamentals. The more you understand the principles that apply in the math when you're looking at the reticles, the simpler it all gets. All right, guys, we got through with zeroing. We've came out to the range. Now we're actually going to get a range card, all right, or gather our dope. Dope was initially the data gathered on previous engagements. That's what dope means, all right? In the past, we would actually gather our dope by shooting at different ranges, starting out at 100, what we did previously, moving to 2, 3, 4, and so on. This would actually take a lot of time, and you'd write all the information down in a data book, and you'd carry that data book with you when you found yourself in a position that was somewhere like something you shot in the past. You would pull that information up and actually shoot the hole that you shot previously, that you got the actual impact that you were looking for. Well, nowadays it's a little bit different, all right? The Army ballistic computer and the ballistic solver that the Marine Corps went with is the A-Trag. It's from Horse Vision. Guys, this will work in meals, it'll work in MOA as far as your holes. The computer works in anything. It's not set to a Horse Vision scope. It can run off. We even teach people how to true their ballistic reticles, all right? In the military and law enforcement, even in the private sector and the hunters, they actually use sometimes a ACOG that is a ballistic reticle or other types of ballistic reticles, all right? But the PDA works with any kind of weapon system. But what you need to understand is it's a predictive polynomial curve. It's still just a close guess, a mathematical close guess, all right? So what we're gonna do is we're going to actually go through the PDA. I'm going to show you how to use it. We'll go step by step. If you have any questions, just blurt them out and we'll walk through them one by one. All right, what I want you to do first, I want you to actually go in and build a gun. So down bottom low left, hit gun list. All right, once you've done that, hit add new gun. All right, then go ahead and name it whatever gun that you want to name it. And a lot of times with a lot of the groups I work with, I want them to name it your name, Mark 13, 191, whatever your ammo is. For the hunter or for whoever else, if you have different types of ammo, you might set up the same gun with different types of ammo. It may be Black Hills, maybe Ruag. If you're shooting the same stuff, you may have a different weight of the bullet, like a 175 or a 168, something like that. So you don't have to go in and change a lot of stuff each time you go into your PDA. You actually just get to go in, down select the gun and ammo combo that you're working in, pull it up, and you're ready to go. All right, now that you've actually named a gun, what I want you to do is go into gun list, select that box by that name, and hit open. All right. From there, what we're going to do is go to up at the top left, it says gun. All right, we're going to plug in all our gun data now. All right, what you're going to see is it's going to pull up a lot of gun information. All right, first is your bore height. All right, you can measure from center of bore to center of scope. All right, and when you do that, somewhere right at your turret. All right, it should be in the center of the bolt to the center of the actual turret on your scope. Now, if you don't have a micrometer or a ruler or something in the field, and we really try and work around doing stuff in the field as much as possible. All right, you can take your finger, and every line on your finger is real close to 1 inch. All right, and I'll show you that it really doesn't matter that much, even at long range, if you're a 1/4 of an inch off on your bore height. All right, so once you've got your bore height plugged in, I want you to plug in your bullet weight. All right. Next, after you plug in your bullet weight, plug in your bullet diameter. Now you're shooting a 30 cal bullet. Unless we're running 5.56, which we'd plug in .223. The next one down is C1 coefficient. All right, that's your ballistic coefficient of your bullet. All right, back in the 1800s, Charles Cupp came up with a way that we actually define what a bullet is as far as the numerical value that we put on it. All right, so he shot a 1 inch diameter bullet, all right, that weighed 1 pound. And when he shot it out, he deemed whatever the actual performance that bullet actually gave him, he deemed that to be a 1 BC. All right, he made another bullet, deemed it to be a 0.5 BC. From that, it's the same way that we look at girls and go, wow, she's a 10, she's a 6. It's the same thing that we're doing with the bullet, all right, but we're just putting a numerical value on it, all right? So really what you're doing now, you're trying to define how efficient that bullet is in flight, all right? How well it will fight through wind, how well it will maintain velocity. That's what we're looking for. So the 175 grain bullets, go ahead and plug in .47. And we'll quantify this a little bit. A lot of the data that you're going to see, the 175 Sierra, they say it is a .496. All right, that's based off of a G1 scale. All right, so we need to talk about G1s and G7 scales. A G1 scale is a higher lenticular curve based off of a bullet that is not as efficient in flight. All right, so with all the math that it has from muzzle velocity and weight and efficiency of the bullet being the BC, it's going to have a higher arc, all right, a higher lenticular curve. Then you have a G7, which is something like you'd use for a VLD bullet, which is a lower lenticular curve or a more shallow lenticular curve. All right, well, if you look at it, really, the ATRAG ballistic solver doesn't run off either. All right, it's a morphed G1, G7 that was actually developed by Bill Davis with all the data that he built shooting through Dopplers. All right, this is actual flight data of the bullet itself. All right, so he took that data, compiled it, Horse Vision bought it, and actually stuck it in a ballistic solver. So we're not really in a G1 or a G7. That's why a true G1 may be somewhere closer to a 496. I'm not going to argue that point. All right, but what we've actually found is the actual G1 is closer to a .47. We've actually shot at 1,000 yards, thousands of bullets, and actually tracked, shooting through 3 chronographs all at the same time to where we had a good close guess. All right, you really need a calibrated chronograph to do this. All right, but based off the actual impact of the bullet, it can tell you your actual BC if you know the velocity. The problem with this, ballistic solvers are predictive, all right, meaning that they're giving you a mathematical guess. Well, if you have a BC that's slightly off, all right, it's going to actually, and you shoot through a chronograph that's even calibrated, but it's actually not a real BC, your ballistic solver is not going to give you accurate data, all right, because you have bad information. It's just a computer. You put in bad information, it's going to spit out bad information. So what we did, we went in and changed it. we have a truing option, which we'll get to in a minute, but I'm going to explain a little bit of why we use a truing option. All right, if we don't know, or we're just getting close to an actual BC for that bullet, all right, and we find out where the bullet actually hit downrange, somewhere around the start of transonic flight, all right, and the reason we do it at that range is if you do it anywhere any closer, you can't see the separation in the algorithm. But the further we go out in clean air meaning there's not transonic shock waves affecting the flight path of the bullet, the further we go out, we see more separation in the algorithm, so we can actually refine it a little bit more. All right, so basically what we do, we tell the PDA where the bullet actually hit. By doing that, we're truing the actual data that the PDA is spitting back out at us. All right, so that's a little quick lesson on BCs and how we actually use them. We'll teach you a little bit later how you can actually go in and figure out the actual BC of your bullet by truing your BC. All right, now, next we'll go into rifle twists. All right, when we started looking at rifle twists, basically guys, your 308s that we're running today, most of them are all around 11 twists. All right, the 300 should be somewhere around a 10 twist. That means there's one rotation in 10 inches of barrel, all right, or one rotation in 11 inches of barrel. So if we have a 15 twist, it actually takes longer, so it's actually a slower twist to get that full revolution. All right, so you actually need to know what your twist rate is of your rifle. It's actually going to give you spin drift. So even with a no wind environment, shooting at distance, your bullet will track off with a right hand twist in the direction of your twist, which would be right. All right, so shooting at 2,000 meters, you know, you say, well, how much does it really matter? All right, shooting out to $1,000, it's really not that much. All right, but shooting out to $2,000, you can have 40 inches of spin drift nearly, all right, at $2,000 in zero wind that you have to account for. All right, so we'll get back into that a little bit later when we start, and I'll show you on the guns how much there actually is. All right, so next we have muzzle velocity. All right, we've talked through a little bit today. The different barrel lengths are going to determine muzzle velocity a little bit, but we're actually going to find our muzzle velocity. All right, the way that we do that is through truing. So we'll go get set up on the weapons here in a minute. We'll lay down, we'll find the exact range. All right, in doing that, we're actually going to use the laser rangefinder. We do not meal the target trying to estimate range, because if we don't do a really good job estimating the range, we're basically gathering data off of bad information. All right, so we laser the target, we know exact range, you plug the exact range in, and from that point, then we can actually find the actual real muzzle velocity that that bullet is flying on because of where it hit. We already know the BC. We're going to have the correct density altitude plugged into the computer. The only other option is actual muzzle velocity, and wherever the bullet hit, it tells us the muzzle velocity. We're not making up anything on our own. We're actually tracking where the bullet hit, and the bullet tells us what the formula needs to be. All right, so once everybody's got through with that screen, your zero range is at 100 meters from this morning. All right, next screen is atmosphere in the middle column. Go ahead and hit on it. All right, you're going to see AT and TBH up at the top. AT is altitude and temperature. TBH is temperature, barometric pressure, and humidity. All right, I like to run on the temperature, barometric pressure, and humidity because it gives a closer resemblance to what the bullet is actually flying through, all right, on how dense the area is. Temperature and altitude gets us close, but we're at 2,700 foot right now, and within a couple of inches until the end of time, we're going to be at 2,700 foot. But because of cold fronts and warm fronts that come through the area, the bullet may think that it's 400 or 500 feet higher or lower than that because how dense the air is at that time. So if you use barometric pressure, all right, you're going to get a closer resemblance to actual denseness of the air with temperature, barometric pressure, and humidity. And humidity doesn't play a huge role, and I'll show you in a minute how much it actually plays. All right, most of the time we keep our humidity at 50%. All right, that's pretty much across the board. You can plug in the exact number if you want to, but I'll show you here in just a minute. We'll make a full swing. You'll see how much actual change there really is. All right, target, you go ahead and hit it. All right, you're going to see latitude and direction of fire in the first two columns. All right, what that is giving us is actual Coriolis. All right, Coriolis is while the bullet is in flight. All right, if you're shooting it at a long enough distance that it has a long enough time of flight, the rotation of the earth, all right, what you thought you were aiming at has actually moved and moved around the rotation of the earth. So if you're aiming at the top of this target, if it has a long enough time of flight, it's moving around the curvature of the earth, and you're actually shooting due east, you're going to hit high. At 2,000 meters, you'll hit close to 20 inches high. Obviously, shooting to the west is just opposite. All right, it's moving to the east, so your bullet is actually going to hit low. You were aiming at the head, but it actually moved up. the perception of where you aimed, your bullet's going to hit that at that spot, but the target actually moved up around the curvature of the earth. All right. So, wind speed. All right. Wind speed. There's two blocks now. All right. There's wind 1 and wind 2. Obviously, wind doesn't always blow 6 miles an hour. All right. So what we did, we went in and plugged in where we could say, hey, wind's gusting today from 8 to 10 miles an hour. So you can plug in 8 and 10, and you don't have to wait for a medium wind to shoot in. All right. It may have spit out, hey, wind's from 6 to 10 today, and you plug in an 8-mile-an-hour wind initially, and so you're having to shoot in the medium wind. Now I know my holes for a 6, I know my holes for a 10, I can extrapolate between those holes at any wind speed anywhere in between. All right, so we're making a more knowledgeable shot at all times. All right, underneath that you have wind direction. This is in clock positions. All right, so based off the line that you're shooting at towards your target, 3 o'clock's going to be due right. All right, 9 o'clock's straight to your left. All right, obviously based off that, it's going to give you a cosine of the wind and the actual value of it. All right, inclination angle. You have C and D. All right, C it says 1 right now and D 0. All right, that means that if we were shooting at 800 meters, you have a full 800 meters, all right, that you're shooting as far as how much your bullet's going to be affected by inclination. All right, so if you actually plugged in 60 degrees, you're going to see that the C is actually going to turn into 50%. All right, so that's what this is. Depending on which inclinometer that you're actually running, you may actually have something that says, hey, I have 30 degrees right now, or you may have something that says 71 or 87, whatever your cosine is, all right, for whatever degrees that you're actually looking at. So that you can plug in either or, and it will change the other one for you. Next line down, target speed. All right, you can plug in the movement of your target as you're looking at it. We can refine this and do this several different ways, but that's what this is for. If the target's moving 2 miles an hour, you plug in 2 there. All right, if you go and look at target range right now, go ahead and plug in 800 and hit done. All right, we'll get back to target speed in a minute, and I'll show you a quick way to actually find the actual speed of the target that you're looking at. I told you to plug in 50% humidity. All right, Travis, I want you to go under atmosphere and change yours to 10% humidity and tell me your hold.
8.67.
All right, 867, change it to 100% humidity.
861.
All right, difference of 0.06 mils. All right, 0.3 mils is real close to a minute of angle. It's 1.08 inches at 100 yards. All right, so what you're going to look at is 0.06. 0.1 is a third of that, right? 0.06 is nearly half of that. So you're looking at a sixth of a minute of angle in a full spectrum of humidity, all right? 0.06, we can't hold it. We hope that we can run somewhere around a quarter minute, all right? A quarter minute would be awesome if we can hold a quarter minute, all right? Most of the guns and ammo combinations that we work with are somewhere closer between a quarter and a half, hopefully. You know, still ½ inch is really, really good. All right, so when you're looking at a sixth of a minute of angle, this isn't something that we really worry about. So by plugging in 50%, what does that do? Cuts that air in half, and now we're only dealing with 0.03 mils, all right, which turns into a 1/12 of a minute of angle. All right, so it's in either direction. So it really doesn't matter that much.
So getting wrapped around humidity, which I hear a lot of people doing, talking the talk, it's not worth it.
Yeah, it's really not. All right, if you're shooting out at extended ranges, and I'm talking 1,500 meters with a 308, then I might want to go ahead and actually plug in the actual humidity. But you're going to see once you start testing and playing with it, even at that, it's not going to be that much off. You know, you're going to have a lot more problems come up that you can't assess whether it was from the humidity or not. All right, shooting at those kind of ranges, or shooting out to 2 grand with a 338 Lapua, something like that. It's not bad to actually plug in the actual data, whatever the actual data is, but you ain't got to get wrapped up on it out to 1 grand, you know, what we're going to be shooting today. All right, so everybody's looked at gun, atmosphere, and target. Then you have truing drop. Now that's what really sets us apart from most of the crowd. The truing drop information is what we talked about earlier. That's what we're fixing to go do. Guys, we can take, after we've zeroed, all right, from that point, we move out, and within 1 round, we can actually get a good true. All right, Jason St. John and Robbie Johnson, a couple of shooters that I know from down at Benning, they were shooting in a sniper comp, and we actually sat down and did a quick demo with them. At 795 meters out, I told them to shoot at a target after they zeroed a gun they'd never shot before with ammo that they'd never shot before. They zeroed the gun, got a good quick zero, turned around and shot at 795. I gave them an errant muzzle velocity. I told them it was too fast. I knew that ammo wouldn't be running that fast, but I knew we could see the miss and see where it hit. All right, based off that one miss, we gave him a second shot correction, which hit center, plugged the information into the PDA. So from that one miss, we had our algorithm. We had a pure range card. All right, now from that, he engaged targets from 300 all the way out to 1,000, never missed high or low over 4 inches all the way out. All right, so.
Like you said, this does set you apart from the crowd. And how did you come up with this concept of truing?
You know, it was what I call cowboy math. I grew up in West Texas. You know, it was common sense approach to everything, ranching and farming. So instead of being a ballistician, all right, and I know that to be more refined, if I had a calibrated chronograph and I really knew the actual BC of the bullet, and that becomes another issue because bullet companies sell bullets by BCs and basically the terminal effects of the bullet that it has on target. All right, so if you're a target shooter or a paper puncher, you want a good high BC, something that's going to fight, win well, and fly good. All right, if you're hunting or doing something else like that, obviously you have to have both. You know, you have to have one or the other. You may have to give up a little bit here, get a little bit, you know, somewhere else. But basically, you want it to do damage on tissue so you can have a good, quick, clean kill when you're out hunting. All right, so when I was looking at that, I noticed that my BCs always didn't match up with what the company said they did. All right, and like I told you earlier, the way I actually find my BCs, and I called Ken Ayler, the guy that makes the Ayler chronograph, and asked him if what I was doing was correct, and he said, absolutely, we're gathering actual data that way. It's an actual BC. And I've talked with Brian Litz. All right, he's a ballistician for Berger, and he absolutely agrees that what we're doing is correct. If you have a calibrated chronograph, all right, and if you know the actual BC of your bullet, then you don't have to true. All right, it's going to give you a good algorithm, and it's going to be a pure algorithm. But the problem is laymen, we don't have access to Dopplers. All right, if you got a Doppler in your backyard, go use it. All right, it'll give you good data. Most of us ain't got one. All right, so what we have to do, based on where the bullet hit, I didn't want to read off PDA because PDA actually gave me errant data. If you're wanting to do headshots at 800, a lot of times if you just go off what the PDA said, you were going to miss. So basically what I did, I said, hey, this is a page that I want. This is what I want it to say. When I shoot, wherever the bullet hits, I want to plug that in and tell the PDA to change all the math to match where that bullet just hit. All right, so minimal starts about, with a 308 today, about 600 meters. That's minimal. All right, up to transonic. Now transonic is right at, in my opinion, about 1,340. I know it's a little bit pre-subsonic, but depending upon density altitude, I don't want to get into transonic flight. All right, so 1,340 feet per second is getting close to transonic. All right, and so that's what we're working off of. All right, so you're going to look at your range card here in a minute. You're going to change your last column to remaining velocity, and you're starting to scroll down until you see 1,340. So go ahead and do that now. Hop into range card up at the top right. All right, once you plug that in, down at the bottom it says last column on the bottom left. Last column, make it read remaining velocity. And you may need to change your setup to 5 meter increment. All right, you can start it at 100, in range being somewhere around 2,000.
1343, that's what I got.
Yeah, that's close. That's good enough. So what range is that at?
810.
810. We need to find a target out here somewhere close to 810. All right, and then we'll actually take a shot on it. And if we're shooting 5.56, 300 Win Mag, all right, the closer you get to transonic, the more pure your algorithm is going to be for what we have access to. Like I said earlier, if it's a calibrated chronograph into the known BC, it's going to give you good data.
So 1340 is that magic number then for any caliber?
Yeah, because it's speed of sound. Yeah, 1,061 plus temperature of the day gives you a close speed of sound, all right, converted to feet per second. So if today's, 70 degrees, all right, 70 plus 1,061, all right, it's 1,131. All right, that would be the speed of sound today. And it's not perfect, but it's within a couple of feet per second. All right, so it's good enough for what we're doing. All right, so the 1340 is pre-transonic flight. All right, what we don't want to do is actually run out and try and true a 308 at 400 meters, because at 400 meters, I can be a minute of angle off. All right, I can be doing headshots on an 8-inch plate at 400. All right, when I do that, the top of my cone, all right, the top of my dispersion on my 1-inch group is in the center of the target. All right, the bottom of it is nearly at the bottom of the plate. I'm calling that, hey, that's just me, that's just me. I'm hitting center, and then you hit one that's a little low and you wanna blame it on yourself. No, you still remember all the good things that happen in life. So you're saying you think you're good. You may actually adjust it up and move it, but the problem is the difference in a minute of angle at 400 is 120 feet per second. All right, once you move out to 800 meters, that same change is gonna be over a mil. All right, so you can't assume what your muzzle velocity is by truing at 400. You need to stretch the algorithm out to see the actual dispersion, all right, and see the difference in where the predictive algorithm is and the actual algorithm is.
So we want to miss by a mile, not by an inch.
Yeah. Any more questions? All right, if no more questions, grab your stuff. Let's go over to the guns and we'll actually sit down and true. All right, guys, now what I want you to think about is your scope has to be exactly level. All right, it's very important. We really push putting bubbles on the scopes, all right, because if you can't as much as 2.5 degrees, which seems to be really hard for people to actually see that they're canted that much. Obviously, looking out here, we're not on a golf course range. This is a real world range, has lots of curves, lots of hills. It's real hard to depict what is level. All right, so having a scope level is real important. If you're 2.5 degrees off, you're gonna hit 1/2 tenth of a mil every 100 meters in the direction of your can of your scope. All right, so if you're 5 degrees off at 800, you're gonna be 0.8 mils in the direction of the can of the scope. So really work hard at leveling the scope, making sure it's as level as possible. All right, Travis, pull up your PDA, go to range card, find 1340 under remaining velocity and tell me what range that is. And y'all remember, this is what we call pre-transonic flight, the transitional period to where the bullet's going from supersonic into subsonic flight. All right, we want to go right up to the edge of it, all right, right before we go into transonic flight.
795.
795, all right? Look out to the left, all right? There's 2 targets on the left side of the range. Go ahead and hit the closer one.
That's 797 at the
All right, that'll work.
So that's perfect.
And it really doesn't matter. You can be plus and minus, 50 meters on this thing. You're gonna be okay, all right? But you really wanna be somewhere around that range. Like we said earlier, if I had to, I could do this at 600 with this weapon system, but it's gonna give me a cleaner algorithm, a more pure algorithm, the further I can go out pre-transonic, all right?
Speaking of the level, it's funny because this particular target where it's at, the horizon looks straight out there, so I naturally wanna put my reticle on the horizon. But when I look at the gun level, it's not level at all. So that's something that people need to really think about.
Yeah, and a lot of times as you look at the target down over the top of the scope, if you level your top turret,
yeah,
all right, it's gonna give you a closer guess than just looking through your reticle. All right, a lot of times out here to mess with the guys for training purposes, as you notice, we hang the targets a little off-centered, all right, to where they're not straight up and down. All right, that's on purpose. And guys, remember, it's real important. We've already plugged in the current atmospherics, all right, barometric pressure, temperature, all right, and humidity at 50%. But we've actually already plugged all this information in. It's very important that this is actual, not a guess. All right, so go ahead and get it good and level. What does it say for 797 meters? What does your PDA say?
8.78.
8.78, your hold, right?
Right.
So go ahead and give me 8.8 in the center of the body on that target. Go ahead and hold left edge. All right, elevation actually looked really good. You were probably belly button height, but your impact was close to 0.7 to the right of where we were holding. So go ahead and hold 0.7 left. And guys, we really don't care. Doesn't even matter if you hit a plate. A lot of times I like to really refine guys on small rocks out at this distance because we can actually see, we don't get caught up. You don't want to just hit steel. If the steel's beat up and you hit steel and you're going, yeah, but I'm hitting the target, you may be a minute of angle low. You may be around 0.3 mils off, 0.4 mils off, still hitting steel and incur bad data for your algorithm. All right, so go ahead and hold 0.7 left, send it again. All All right, it was just off the right edge, nearly center for height. So we did a good job estimating the actual muzzle velocity of the weapon system. So go ahead and give me 1 mil left. Good, it's a nice hit. All right, you hit just under the lower chin. Send one more to confirm. All right, it's a headshot. All right, so you're holding center body?
Center body.
All right, from that, I want you to mill it and tell me how high you're actually hitting above where you're holding. You're about 0.3 high, correct?
I am.
All right, and you were holding 8.8?
My impact is 0.8 high.
0.8 above where you're holding?
2, 4, 6.
I tell you what,
no, it's
the
6,
average hit's about 0.3 up, so you were holding 8.8. Give me 8.5, center of the target.
8.5.
And all you have to do, guys, is just place the 8.8 where you're holding and look at where it was hitting on your reticle. Center body, left edge. All right, so now what you do is you go to your home page, go to options in the bottom left. Once you pull up that, you're going to go to truing drop halfway down that pop-up screen.
Okay.
Under the range, you're going to see a drop of 8.8 in a white column. Change that to 8.5. All right, hit calc on the top right.
Got it.
All right, and then hit use MV, and then hit accept. All right, once you've done that,
Okay.
look under your gun information. What is your muzzle velocity?
25.75.
All right, good deal. All right, now, Travis, what you're going to want to do now is go into gun list, select the gun you're working in, and save your gun so you don't lose all that good data. And guys, really, it's just that easy to actually find your data book or your dope. All right, perfect dope, and we could have done him in one shot. All right, he actually hit off the right side. All right, then he hit the target consistently, just barely high. We actually told the PDA where his bullet was hitting, and now he has an actual algorithm. All right, so once you save that gun data, you're good. And that would be good information to actually write into your actual data book now, is what the muzzle velocity was on this lot of ammo. Once you shoot out to that distance, you want to come back in and confirm at a medium range, because if you did anything wrong with your data for atmospherics or gun data, you're going to have an error in your algorithm and you won't hit where you're holding. Now, what we're going to do real fast to verify, you see the target that's about 400 meters out, the one just underneath the heel?
Yep.
All right, range that target.
405.
405. Plug in 405.
.5.
2.5. Go ahead and give me 2.5 on the target and hold 0.4 left. This is just confirming that we really do have a good algorithm, guys. Give me 0.4 wind, which is left edge. 2.5 center body. Fire when ready. All right, center hit. Good job. All right, Chris, you're up. You're going to do the same thing, so you're going to plug in 797 into your PDA for target range.
I've got 8.7 is what mine's saying.
All right, give me 8.7. You're shooting 308, correct?
Correct.
All right, go ahead and give me 0.7 left. All right, just off left side elevation was good. Give me a center wind. Nice hit. You hit right on Travis's bullet on the left side. Go ahead and hold right edge. Give me another shot. Just up above on his left shoulder, just probably 4 inches under his left shoulder. It's still well within half minute of angle on the target. That's good, both shots. All right, so we know we have a good algorithm. Go back in, make sure you save the gun. All right, Mike, same deal. All right, just give me center wind.
8.78.
All right, so you'd hold 8.8. You just round that last number up. Headshot. All right, you were holding center body?
I was.
All right, go ahead and give me another shot. We'll confirm. All right, we'll stay with 0.5 right. Headshot again. All right, so from where you're aiming, look in mils, how far it is to where your bullet is hitting. Looks like about 0.4, correct?
That's what I'm getting to.
All right, so you dialed on 8.8, so take 0.4 off, come to 8.4. All right, go ahead and give me another headshot. Aim with your crosshair on his head now. Good shot. Another headshot. Stacked all your bullets right there together. For your 300 win, we're going to push this out to 1,038.
Well, Todd, I found that really interesting. I mean, just conducting a test, of just expanding on the zero at a range we once thought of as the max effective range for the weapon system.
You know, it really is. Used to it'd take, you know, a couple of hundred rounds to actually lay down and shoot at 200 and 300 and 400. And at that time, you're actually incurring human error into your dope book, all right? So while you're gathering your dope, you're actually incurring all the errors that we put into it. So what we're trying to do is actually just take out the human error as much as possible, gather the data at the maximum range pre-transonic, and then once you do that, you have a perfect algorithm all the way back. And really, you did 3 headshots at 800 meters, all right? Which a 308 used to, they thought that was the maximum range. We'll push that gun out to a mile, and you'll stay on that same 16-inch plate at a mile with it.
I'm looking forward to it.
Yeah, it is amazing. It's interesting, but you know, it's a deal. It's not hard. You know, in a lot of schools, they used to teach that 800 was kind of give or take. You know, you'd hit some, you'd miss some, and obviously as wind increases, it's going to get hard to call wind. You know, the reason we come to West Texas for training is wind is constantly, you know, 15 to 20 miles an hour every day. You know, we've been real lucky, you know, today the wind wasn't really blowing that much, you know, but it's still tricky because of all the terrain features. You know, wind changed left and right. Nearly every time somebody got up is a different wind for them, you know, so the winds out here every 5 miles an hour, you lose about a 10% hit probability. You know, it sounds like a lot initially, but you're 4 really good shooters. But I promise you, if you lay down tomorrow morning and you say, okay, there's a target at 800, you have a perfect dope book now. You have a perfect, you know, range. You lay down, take a shot. If the wind's blowing 23 miles an hour, I promise you, you know, you're going to have about 6 out of 10 guys be able to make the shot and hit and connect past 600, you know, by calling their own wind, making their own judgment, and making that shot. So that's why we come out here. It's not hard, and you can do it very fast.
And like you said earlier, the greatest thing about this concept is the minimal amount of ammo. I mean, like you said, Mike just made 3 headshots right after he just got done zeroing. And we did that at 800 yards, and we confirmed at 405. So we just saved a lot of time, money, and effort, where normally we would do exactly that. 100, 200, 300, 400, 5, 6, 7, 8, 9, 10, and how many rounds and how much human error is going into that with body position and all other stuff. That's a really great point.
Yeah, absolutely. And you brought up something good. That zero is very important. If you have a bad zero, guess what's going to happen?
Everything
when you shoot
else
out at
magnifies.
range, you've got bad data now. So you may hit, you'll be perfect at 800 because your bullet just hit there. But those interim ranges, that's why we went back and checked at 4. If you had a bad zero, it's going to start showing up at that distance. So,
well, the other part was the fact that you said the bullet doesn't lie, because when Travis first shot, he had to make some adjustments based on some speed. And the fact is, you can argue that all day long, or you can enter in the correct data of what it actually is, and therefore really true to the gun and the bullet and everything.
You know, it's really interesting. The truing deal is really scientific. You know, even though it's kind of a cowboy method of getting, it's kind of like doing the backwards math, you know, to getting your data. But it's very scientific in that that's where your bullet just hit. Why would you want to argue with your bullet? So if that bullet doesn't get to vote, once it leaves that barrel, it's going to have the same drop due to gravity every time that it goes out. So if you have the correct density altitude, if you have the correct BC, the correct muzzle velocity, it's going to hit at the same point. We may not know the exact BC, the reality of it. We may not know the exact muzzle velocity, but as long as we get really close on our BC, all right, go off of, you know, the factory specs of that bullet, all right, and true, if you actually go off the factory spec of the bullet and it's slightly off, and guys, I have 2 good chronographs, and we interlink them and shoot through both of them at the same time, and they're high dollar chronographs, and they're 20 feet per second different than each other. All right, so that 20 feet per second at that target distance is a miss. All right, so we can't go off that. He couldn't have made 3 headshots if he was 20 feet per second off. All right, so what you really got to do is accept that even though you may be a little bit low on your BC, your muzzle velocity is going to actually be a little bit higher in the PDA than what may be reality on a calibrated chronograph, but it doesn't matter because the algorithm is going to be correct. All right, you may be slightly off, but it's going to be less than what the minute of angle of what you can shoot and what the gun can hold. All right, so it's still a very accurate algorithm to actually use.
All right, so what's next?
What's next is we'll actually learn to use a PDA. All right, so we're going to range targets, plug the information in, go from 300 meters all the way out to 1,200 meters. And with the big guns, we'll actually even push out further. Then after everybody feels comfortable and they understand how to use everything, we'll even go further than that. We'll push out to a mile.
Well, that's certainly going to be interesting going out to a mile with 308.
Everybody does it. Everybody in the class hits a 16-inch wide target at a mile.
Well, let's do it.
All right, let's go.